So hello everyone, welcome back to my channel. In this video, we will discuss about that CodeChef Starter 110, which is held on recent Wednesday. Okay, last Wednesday. So that's problem rating is 485, and that's problem name is water park. So I hope you have solved this problem. So this is a very basic problem of this. So let us discuss about that problem statement. So, Chef decided to go to the water park to play. Okay, to enter the water slide, a person must have a weight of WkG and their height at least s centimeter. Means of that, means of that, the constraint to enter the water slide is their person having a weight WkG, at most WkG. Means of that their weight is 0 to till WkG. Okay, and their height is s centimeter, at least s centimeter. I'm just explaining you if if the weight is decidable that 60 kg, suppose of that, okay, is 60 kg. So behind this 60 kg, suppose of that, if the person having a weight 59, 58, okay, 57, or 60, so he is valid, and he can go to that water park. And another constraint is that height is at least h h centimeter. Means of that, suppose of that, the water slide has to be decided the height is 130 centimeter. Means of that, at least height should be 130. Okay, 130, 131, 132, 132. Okay, so he can valid. Otherwise, their weight is 64 or 61, and their uh, height is 125. So he does not enter. This constraint weight and height does not enter. Either it is or either it is. Both are not uh, both cannot enter into that water park. Okay, I hope you have understood very well. So here is the code. So this is a weight and height, and this is I'm just getting that input, and this is the constraint, and if it is valid, then yes, you can simply print it. Otherwise, no. I hope you have to be very understood, and this is working very fine. You can check that. Yes, successfully executed. uh, so we have to move on next problem. Okay, so in an aeroplane, operate X aircraft every day. Okay, in an airline, sorry, in an airline, operate X aircraft every day, and each aircraft can carry up 100%. And suppose of that aircraft can carry 100 per passenger each. Means of that every day. One day, n passenger would like to travel to the same destination. Okay, so I'm just giving some example that one day that n passenger would like to travel to the same destination. Okay, what is the minimum number of new plane that airline must be carried to all the n passengers? I hope I'm just explaining you that what does the problem says. The problem is statement is that in an airline they have a X aircraft. Okay, they operate the X aircraft every day, and each and every day, they carry up to 100 passenger. Means, suppose of that, this is the source destination, and this is the uh, endpoint. Okay, so each and every day, aircraft will carry the 100 passenger to shift from that one destination, one source to another source. Okay, uh, so so suppose on but we have to be given as some condition that on one day n passenger would like to travel to the same destination, means of that n person would like to travel from the same destination. Suppose this is the n passenger and they want to be get that I want to be moved from this destination to this destination. So which is extra? Which is extra? Suppose he is carrying, we have to be already given that he is carrying 100 passenger. Okay, and this carry more than n, more than 100 or less than 100, which is to be given on according to our situation. Okay, so what is the minimum number of new plane that the airline must buy to carry all n passengers? Okay, so now we have to be getting that how you can determine that all our n number of passengers you have to buy all. Suppose of that according to this given statement. Suppose of that I have only 4 plane and the number of passenger is 600. At that time, you know very well that our aircraft is 4 and number of passengers is 600. This is our aircraft and this is our passengers. Okay, so in at that time one aircraft, because already given that it's one aircraft will carry only and only 100 people. Okay, so for the 600 people, for the 600 people I want to be getting, I want to be getting 6 aircraft. You know very well, I hope you know very well that what is the problem statement. Okay, so that time we have to be getting 2 more aircraft, which is already having given a 4 and I want to get that 2 more aircraft. Understood? What does it saying that? Suppose of that I want to discuss another example. Suppose this is our 5 aircraft I have given. Suppose an aircraft 5 aircraft has been given and number of passengers is 523. Okay, so how much you will getting? You will get, you will get one more. Why? Because of that 5 will carry the 500 and remaining 23 people will be left, which is required for the, which is required for 23 people for the one aircraft. Okay, means of that for the 23 people will be getting by the one aircraft we have to be a buy. Okay, oh so yes, so but their constant is the 3, so you know very well that what you can say that. And this is our another example. I have suppose I have a 8 aircraft. I have a 8 aircraft and number of passengers is 245. Okay, so 245. So how much you will get? So you know very well that I need only and only 3, but more than 3. So we don't know we getting any of the aircraft. Okay, so at that time we will 0. Okay, so how you can solve it? So very simple problem. We will simply take the test cases, and each and every test cases you will simply initialize by the input, by the user input, which is x and n. And what is the x and n? The constant is already given that x and n, and x and n is already defined that, each and every test case is x will be aircraft, x is aircraft and n is number of passengers. Okay, so how many purchase aircraft, how you can get that? We will define n divided by 100. Why? Because of that, suppose of that I have 245 people, number of passengers 245. Okay, now when we will divide by 2, when we will divide by 100, okay, so we will getting a quotient which is 2. So which is a 2. Because of that, number of purchasing aircraft is not getting. And now if we have to be getting a condition, if purchasing aircraft is equal greater than equal to x, means of that this number I have getting this number is greater than equal to x, and number number of passenger is divisible by 100. Number of passengers is divisible by 100, means of that there are 200 or 300 people. So that's time what we will do, we will simply number of purchasing per aircraft is uh, purchasing aircraft minus x, means of that suppose of that I'm just again explaining you, I have only 200 people and aircraft is only one. So how much you will get, you will simply divide by 100, divide by 100, and the question will be 2, and the number of purchasing aircraft will 1. Okay, this condition, this is used for that condition. Else, okay, that is for the else condition. If it is not divisible, suppose of that 245, okay, or 276, randomly, or random number, for the random number, when we will divide by 100, so what you will get, you will simply getting, you will getting the question 2, but at that time they have more than passenger, more than that, so that some remaining a passenger having left, so that's why x plus 1. Because of that 2 plus 1, because we have to be getting one more aircraft, one more aircraft. I hope you will getting some you have to be know about that what is the statement. Else else what does the statement is saying? Else means of that other condition, suppose number of aircraft is much greater than, or suppose number of aircraft is equal to that number of passengers, so that's why we will getting simply 0, because nothing aircraft we will buy. Okay, so this is also working very fine. Yes, so which is successfully executed. Okay, so now we will move on another problem, that is difficulty rating is 941. Okay, and the problem statement is am I lucky, am I lucky. So let's discuss about that problem statement. So in this problem statement, a school has organized a field trip for class and student, okay, of which X student are boys and the remaining students are girls. Okay, everyone is excited to trekking and must form group of size exactly k to do so. Means of that a school organize field trip for class n student in a class which is having student n, of which x student are boys and the remaining student are girls. Means of that suppose in a class number of student is 50, randomly I'm just saying that. So and 28 are boys, so remaining is that 22, so 22 are girls. You know very well, you can get that how much the boys and girls. Okay, so no need to be getting, and everyone is getting to tracking and must form group of size exactly k. Okay, so everyone is exactly excited to go trekking and must form group size key. So basically, he has to be uh, making a group. And what type of group? I'm just which is also given. So the boys will only form group among themselves. So boys will mix own group, and girls will only form group among themselves, and girls will form only among themselves. Okay, girls will form the group with girls, and boys will form the group with boys. Okay, so both boys and girls will form as many as possible. Means of that they can make the form, they can make the group as many as possible, as possible, but the condition requirement is that each group having a student is key. Okay. Okay, the remaining student can either dance around a bonfire or just read a book. Suppose of that you can know very well that in a group trip, someone have to be dancing into that bonfire, which is uh, around that burning of this something, and you will around and around dancing. Okay, so these types of the dancing, and dancing around the bon or reading a book. Okay, so the reading is much more boring than dancing, so a student will try to avoid it. Okay, so reading is obviously that boring than compared to the dancing. So you need to be go that minimum number of student who will be engaged in reading. So you will simply getting that minimum number of student. So to engage into that reading. Okay, how you can determine? First of all, just move on that test cases. Okay, so this is our sample, which is 12. Suppose of that there are 12 student. Okay, there are 12 student and 4 boys and 3 girls. Okay, so there are suppose this is n, there are 12 boys, there are 12 student, number of boys are 4 and remaining are girls. Obviously that number of girls is 8. I hope you know very well that. And the key size is 3, means of that the group, the number of group of the student, each group of the student would be key, which is 3. I hope you would be understand that. Means of that each and every group having a size 3, it is compulsory. Okay, so how you can solve it? So how, how much a group can be made by the boys is 1, because there are 4 student and one group having a 3, and so the number of group would be from the boys side is 1, and the one student would be left. One student would be left. Okay, into that girl side there are 2 group can be formed from the girl side. Girl, this is the group for boys, this is the group for girls. I hope you know very well that. Okay, and in this remaining student that 2 girls would be left, which is not as a part into that group. Okay, so our statement is that the remaining student either can dance or either can reading the book. Okay, so how you can solve it? You will simply, for that also that a condition that either a dance, the dancing around the bonfire, a pair, so which is a requirement is that. So if you will getting a dance, so you can will be the pair. And what type of pair? Pair of one girl and one boy, which is already given. Okay, one girl and one boy. So this is a one boy and this is a one girl. So this is a pair of the dancing. Okay, and the remaining, so the minimum student is one. I hope you know very well that. So this is one student would be left for reading the book. Okay. Now another test cases is 15, 10, and 5. So means of that 15 are boys. 15 number of student, 10 are boys, and 5 are girls. Okay, and this is the k value. This is a boys. This is a number of student. So number of girls is 5. Okay, you know where you solve this problem. Okay, you, you can simply solve the to that girls. Okay, so the number of group, the girls group only can form that one, and the boys group can be two. Okay, and whole of the group would be considered all the student. So that's why no one can read the book. I hope you would be simply understand that. And last one, the test cases is 883. 883 means of that 8 number of student and 8 number of boys, because they don't have any girls, and 3 of the pairing. Okay, so how you can solve it? So uh, they are having to make a two group. Okay, and two would be left. So remaining, because they don't have any pair, so the remaining is 2. I hope you know very well what does the statement saying and what does that problem example. So now how you can solve it? You will simply getting n, k, and x, and you will simply getting the girls by n minus x. Okay, the boys group, how you can determine? K minus k divisible by x. Okay, so I am just simply getting that. How you will determine that number of boys group? Number of boys group is that number of boys group will be that uh, n divisible by 5. So there are two groups. Okay, so you can simply solve this, and simply as it is that a girls group, the remaining boys means of that x minus boys group into k. So remaining boys is this and remaining girls as it is. Okay, and now what you will do, you will simply print this remaining boys minus remaining girls, means of that remaining boys and remaining girls would be minus. So that's why so that's why so that's the answer of that, which one is that? Reading the book. Why? Because of that each and having a pair. So the after that making a pair, so remaining student which would be reading the book. Okay, I hope you know very well that what this problem statement and what is that solution. Okay, so now move on that our next problem, which is having a difficulty rating is so high, which is 1385, and the problem statement is that marbles. Okay, so chef has a marble and his friend has b. Okay, so now what does statement saying? Chef has a marble and their friend is having a b. Clear my point? And chef, but they want to redistribute among themselves. But they want to do that redistribute means of that someone who having getting this, their friend having this, and they want to be that rearrange about it. Rearrange means of that redistribute about it. Okay, so that the redistributing condition is that Seth and his friend both have at least one marble each. Means of that each Seth and their friend having at least one marble. Okay, each of the person, and the number of marble with Seth. The number of marble with Seth is divisible by the number of marble with his friend. Means of that. What does statement saying? The number, suppose of that Seth has 10 marble. Seth has 10 marble and their friend have a 2 marble. So it is valid. Uh, so it is a valid. Okay, this is a friend, their friend having a 2 valid. Because this their marble would be divisible by their friend marble. Okay, I hope you know very well that. So what is the minimum number of marble that need to be transferred from one person to another to achieve this? Means of that to number of marble to exchange between the chef and their friend. I hope you know very well that what is the problem statement. Now move on that problem example. So the problem example is that they having a seven marble having a chef and two having a their friend. Okay, chef having a 7 and their friend having a 2. So how you can distribute minimum number of exchange? How many minimum number of exchange of that marble is 1? Why? Either he can give the one marble, or either he can give the one marble, because if he can give the one marble, so chef remaining marble is 6, and their friend having marble 3, so 3 divisible by 6, which is valid. Okay, now chef would be given, so they have a, when chef will be take the marble, so they have a 8 marble and their friend having a 1 marble, which is also valid. Why? Because 8 is divisible by 1. Okay, according to this given state, according to that given condition. Okay, which is true for both of this. So minimum number of marble is 1. Okay, so 10 and 5, 10 and 5, which is not be share, which cannot be exchangeable, because 10 is divisible by 2 obviously, so that's why we cannot be exchanged between them. 6 and 5, 6 and 5, yeah, 6 and 5, 6 cannot be divisible by 5. Okay, chef have 6, their friend have 5, so how much he can transfer it? He can transfer that 4 marble, so they have a 10 and they have a 1, so it can be divisible. So minimum number of marbles should be exchanged is 4. Okay, and now the next is, last is 5 and 6, which is last example, 5 and 6. So 5 having a chef and 6 having a friend, their friend. So how much number of marble would be shared? their friend having more than chef, so they will simply giving to that 5 marble. Why? Because chef will be getting chef would be after taking a 5 marble, chef having a 10 marble and their friend having a 1 marble, and the 10 is divisible by 1, so minimum number of marble would be exchanged between them is 5. I hope you know very well that what is that problem example. Now how you can solve it. This is a very real problem, valid problem, that how you can solve it. Okay, simply between that you will simply getting first time is which one is that maximum, either their chef, either having a chef, how much. Okay, chef, suppose of that chef having a 10 and their friend having a 3. Okay, so what you will do, you will simply first time, either you will give it. Okay, if their friend having a number of marble which is divisible by them, okay, so we will stop it. Okay, and the next condition is that, and the next time what we will do, we will simply take it from their friend. Okay, suppose you are a chef and you they have, and your friend is someone your friend. First time what you will do, you will simply give it if you have a more than their friend mark. Okay, so you will simply first of all you will give it. Okay, till until uh, when their friend marble would be divisible by your marble, means of that your marble should be divided to the chef marble. Okay, chef marble simply is that chef marble is divisible by their friend marble. Okay, or either it would be, suppose of that it would be take it, chef would be take it until and unless when their marble would be divisible by their friend marble. So this is the logic behind this, in this whole scenario. I hope you have to be simply understand that. Now how you can solve it? Suppose of that first time what you will do, you will simply give it 10, so you will give that their friend which is having a 3, so 10 giving the 3, so they having a 4 uh, and so yeah, so they having a 4 and they having a 9, so it is divisible, no, again you will take it, yes, they having a 5, they having a 8, is it is divisible, no, again you will give it, you can take it, 6 and I having a 7, it is divisible, no, what you will do, you will again you will give it. Okay, so they having a 7, this having a 6. Okay, it is divisible, no, each and every time you will check it, again you will give it, having a 8, having a 5 until 1, because the condition is that both having getting a 1. Okay, and 12, so but this is not divisible by them. Okay, now the next portion is that, so minimum number of exchange is that each and every time we will count that exchange, because of that counting 1 2 3, okay, 4 5, and remaining 4 marble would be exchanged, so 5 plus 4 is 9. Okay, so they are minimum, so in this way this is having a exchange is 9 marble. Okay, And now another situation is that, another possibility is that chef will be take it. Okay, when chef will be take it, so they having 11 and they having a 2. It is divisible? No. Again it would be take it 12. It is divisible by 1? Yes. So how many count is 1 and 2? So we will simply check that. Which one is that minimum? Either 9 or 2. So we will simply getting that 2 is the minimum. 2 is the minimum. Okay. So this would be written. So simple logic behind this. Now this is a problem and this is the solution. We would be taking that marble A and B from the user. Okay. Boolean first false, second false. I'm just explaining you later why we will initialize that boolean. If A is divisible by B, first of all we will check it. Suppose of that they having a marble 10, chef having marble 10 and their friend having marble 5. So why we have to need that to getting that process. So we will simply return that 0. I hope. Okay. And else condition if it is not divisible. So what we will do, we will simply initialize count 1 and count 2. Why? Because of that counting for that both the process. Either we will take it, either we will not take it. We will simply initialize that temporary A1 and temporary A2 and B1. Okay. Each and every time we will check that A1 is greater than equal to 1. Okay. Because of that we have to be getting at least one marble each and every person, either chef and their friend. Okay. So if it is divisible, if it is not divisible, then what we will do, we will simply give it give it to their friend, or we will increase our count. Okay. Else part is that if it is if it is the condition would be false and the value is divisible, then we will simply return the first is true and we will simply move on that and loop would be break. Okay. Again we will initialize that a1 by a and b1 by b. Okay. Now we will again the whole process would be taken by the b. So we will simply exchange by the we will simply take by the b1. So b1 will be given giving, and each and every time if would be divisible by, if would be divisible, then we will simply true. Huh. So why we have to be require that first true and second true? I'm just simply explaining you. Suppose of that this is having a 10, this is having a 3. Okay. And for this scenario this is not divisible by, this is not divisible by. Okay. This is not divisible by, and our whole loop would be ended according to this condition. When we will take it and 9 time, after the 9 time which is not divisible by, and we will move out from the while loop, but our boolean would be not updating. That what does it means, which is false. And what does it means? It means is that in this process, for this process there are the nothing of the chance to get that, to get the count would be divisible by, to get that marble divisible by their friend. Okay. So that's why we have to be getting the boolean value. Okay. So after that, if first is true and second is not true, means of that count 1 is should be display. Why? Because of that this is the chance. Because of that, second would be not be having because this part it will not run, and the whole scenario will not that while loop would be ended, because they count, because of that count would be not divisible. Okay. Okay. So uh, we will simply return that count 1. Else if the first is not divisible and the second is true and the first is false, so we will simply return count true, count 2. Else part, the else part is that minimum of count 1 and count 2 means of that both are true, both having a, for the both condition it would be getting a getting a divisible by the chef marble. So we will simply return the minimum because our need is that minimum number of marble. Yeah. So I hope you know very well that problem statement. If you know very well that, so please like my video. Please subscribe my channel. If you have any types of doubt, so please comment on my channel. Please hit the subscribe. Please like my video, subscribe my channel, and hit the bell icon. Thank you.